Okay, hello everyone. I'm Yas Naui. Today I'm going to talk about multiple cloud orchestration and resource optimization based on our experience and activities. So call me Yas. Let me introduce myself. I'm a chief architect of cloud at Docomo Innovations in Palo Alto. So Docomo Innovation is a Silicon Valley office of Docomo, which is the biggest mobile operator in Japan, like AT&T, Verizon, T-Mobile in the US. So this is today's agenda. So first, I'll talk about our multiple cloud orchestration concept, cloud orchestration and optimization. And then today's main topic, our cloud orchestrator and resource optimization. And then I'm gonna show you the demo. So this is a screenshot of our cloud orchestrator. We are contributing this software as a cloud module at Drupal.org. So let's start with multiple cloud orchestration concept. We have IT executives, operations, and users in the enterprise organization. Also, we have AWS, Azure, GCP, and on-premise cloud infrastructure. Actually, Docomo headquarters is using those five public cloud, five cloud service provider, including the such as OpenStack and VMware. And in order to access to the cloud, we need to multiple cloud orchestration for the usability and cost management. Actually, it's $1 million per month we are spending the cloud infrastructure and then cloud governance and the workflow automation to integrate those pillars. And this is what we think about a multiple cloud orchestration concept. And let's move on to cloud orchestration and cost optimization. So we have public cloud and on-premise, as I talked, and we have common computing resources and GPU resources. And then nowadays, we build abstraction layer on the top of computing resources using Kubernetes to manage containers. And then we build the application or service. So this is 2021, the current situation of the latest cloud computing architecture. On the other hand, we need to manage cost because we are spending $1 million, more than $1 million per month. And in order to manage cost, we need to resource analysis. And then when we can manage the cost, we need to optimize it. In order to optimize the cost, we need to optimize the computing resources too. And on the other hand, we need to cloud governance to manage those cloud because we are lots of computing resources. And then also cloud security is our first priority and the most important thing, especially in our company like a Docomo, because Docomo is handling privacy data, such as a subscriber ID, your mobile phone, smartphone number, name and location from our customers using smartphones. So we cover cost optimization, cloud optimization and orchestration like this. And in order to implement this big picture, we are focusing on multi-cloud orchestration. So let's move on to the cloud orchestrator features. So this is the screenshot again of cloud orchestrator to manage Kubernetes cluster, for example. So cloud orchestrator can support multiple cloud service provider such as AWS, Kubernetes, OpenStack, VMware, and even Terraform Cloud to deploy computing resources. And basically, Cloud Orchestrator is a cloud management console powered by single sign-on SSO. So for cloud resource optimization, Cloud Orchestrator can support to manage Kubernetes resources. And then for cost management, Cloud Orchestrator supports AWS and Kubernetes. So, okay, so then let me talk about the resource optimization a little more. So this graph shows the resource usage. Actually, this is based on our actual, the Docomo's traditional, typical, the usage. The horizontal x-axis shows time, right? The vertical y-axis shows the ratio of the resource usage. So let's think about your smartphone users' access. So we have high volume mobile internet access from smartphones during the daytime like this. But yes, this is, as a mobile operator, we have a computing resources to provide some services. But however, the resource is not fully used during the nighttime. So we deploy the full computing resources to handle the lots of traffic. Actually, half of the population in Japan are using the Docomo's network. So we deploy the computing resource free like this. But the resource is not fully used during the nighttime because they are sleeping. We are sleeping, basically. And again, during the daytime, the resource usage is full. So basic question is how we can utilize the unused resource during the nighttime, because we are making a lot of upfront payment as a fixed cost. So this is the important thing. In the public cloud like AWS, we can pay as you go. We can do pay as you go. But in a Docomo, we are spending the $1 million per month. So we are making the upfront payment as a fixed cost. Even that is the on-demand, we can get the on-demand access. Because the on-demand access is, we have a lot of resources, and then versus upfront cost is more cheaper, and we can get the more discounts. That's why we are making an upfront payment for the public cloud provider. And then so our basic idea is that we may be able to accommodate the other application software during the nighttime and make it run by using the unused resources. So this is how it works about the resource optimization. So what kind of the resource we can accommodate during the nighttime? So for example, batch processing, not to the online access. We can get some batch processing application during the nighttime. So that is the basic idea. And then so our cloud orchestrator make it possible. So let me show the demo. So let me share the let me share my screen. Oh, I lost yet Zoom. Oh, how can I switch? Oh yeah. And then this one. Thank you for waiting. Yeah, so this is the cloud orchestrator, the dashboard. And as you can see, we can, our cloud management platform for, public cloud and private cloud globally. So we can visualize the public cloud and the private cloud location in a world map. So AWS has, US West and US East. And here I'm in the Silicon Valley. We are deploying the Kubernetes cluster. So this is a Kubernetes icon, and Europe. And we are working together in India. Actually, our engineer in India are making, developing OpenStack portion. And we have the engineer in Japan. So here, AWS resources, the management, like AWS trusted advisor. So we can visualize some, unused Elastic IPs and this associated snapshots, long-running instances. So, well, this is, giving us some visualization and some idea which resource we need to delete or terminate. And here, low utilization instances. Currently, we don't have anything. And also stale snapshot. We need to, delete and clean up and housekeeping like this for the, unused volumes. So this is the, AWS, the resource management dashboard. And then when we go to, for example, AWS Oregon region, and then this is, the dashboard of the AWS for instances, images, security groups, Elastic IPs, key pairs, and so on. So those are the, exactly the same AWS management console. So the reason why we built the AWS management console based on the Drupal by ourselves is that, we want to provide our users for a unified interface. Because, if we switch to Kubernetes cluster like this, so we can restart the Kubernetes Kubernetes cluster 1, Kubernetes cluster 2, and Kubernetes cluster 5. And like AWS, we can, visualize the nodes and namespace and deployments of the Kubernetes. So back to the dashboard, and we can see the Kubernetes Kubernetes resources. And then you can see the I got back to the Kubernetes AWS dashboard, and I can switch to the Kubernetes dashboard like this. How many cores we have and how many the cores we are using, and the right hand each box shows here some the pods in Kubernetes. You can imagine those are the container. And we can visualize like a heat map, which pod is using high CPU usage, like that. And again, this is Kubernetes node cost. We can visualize and we can calculate how much we are using to the one cluster on one node, like this. And also in each namespace, we can see which project is how much we are using. So this is kind of a distributed calculation in a cost. And then so go back to the Kubernetes, the resource management. We can dig into the detailed resource allocation. And also, as you can see, we have the OpenStack cluster. So this is totally, unified, unified interface in the public cloud and the private cloud. And then for the deployment, we can, integrate with the Terraform cloud workspaces. When I click this one, from our cloud orchestrator, we can manipulate Terraform Cloud to deploy those computing resources like AWS or Kubernetes. So through the Terraform Cloud, we can manage every single public and private cloud. So that's how it works in a cloud orchestrator. And so that is my presentation. Thank you so much for listening my presentation. Thank you. Any questions?
Yes, thank you very much for coming to Stanford and showing us this.
Yeah, my pleasure.